In this video, I will give you an example about how to find the inverse of a matrix and how to solve a system of linear equations. Okay, first of all, I will start with the inverse of a matrix. How can I find the inverse of a matrix A? For example, how can I find A minus 1? Okay, I have a matrix A of order 3, it means 3 rows and 3 columns. We call it square matrix. Okay, to have an inverse matrix for a given matrix A, the determinant of A must be different to 0. So the first step is step 1. Verify that A is different to 0. How to calculate determinant of A? Let me show you. So plus, minus, plus. I choose the first row as coefficients. Okay, I start with the first one, plus 1 times this determinant of this matrix, 1 times minus 1, minus 1, minus, minus, plus 2 times 2, plus 4. Okay, second coefficient, minus 3 times, so I choose now this matrix. Okay, 2 times minus 2, minus 2, minus 1 times 2, okay, minus 2 also. Okay, the last coefficient is plus 1 times this determinant of this matrix, 2 times minus 2, minus 4, minus 1, equal to minus 1 plus 4 plus 3 plus 3, minus 4 times minus 3 plus 12, okay, and this one is minus 5. It's equal 15 minus 5 equal to 10, different to 0, which means that A is invertible, means A minus 1 exists. Then now I'll apply Jordan method to find the inverse of A minus 1. How do I do it? I'll show you now. So I'll start with the initial matrix A, which is equal to 1, 3, 1, 2, 1, 2, and 1, minus 2, minus 1. Okay, so in the first step, okay, what I have to do with Jordan method is to move from matrix A to the identity matrix I3, okay, like this, A to I3, okay, using some operations, then use the same operation used in the first stage to obtain the last matrix A minus 1. Okay, so how can I go from A to I3? So I will apply the method now. First of all, this method is based on choose the pivot elements on the diagonal, okay, make them 1, then the elements below them and above them must be equal to 0. For example, the first one is at 1. 1 is already 1, so I don't need to change anything in the first row. So first row, row 1, stay as it is. Okay, nothing changed in row 1. 1, 3, 1. Okay, what I said in this method, so the pivot element, the element below it, he must be 0. So I have to change 2 to 0 and 1 to 0. Number 2 is in row 2. So I must apply the appropriate operation to obtain 0 in the first element in the second row. Okay, so row 2, the new row 2 must be row 2. So what operation can I make between row 2 and row 1 to obtain 0? Here it's 1 and it's 2. If I make it 2 minus 2, so it should be 0. So how can I make row 1 equal to 2? I multiply it by 2. So row 2 minus 2 row 1. Okay, so I obtain 0 minus 5 0. Row 3 also, the entry in the row 3, the entry must be equal to 0. So what operation can I make it between this one and this one? So simply I make the difference between them. So new row 3 must be old row 3 minus row 1. Okay, so I obtain 0 minus 5 minus 2. Okay, this first operations I make them. So I finish the first pivot element. Now the second one here, second element on the diagonal must be equal to 1, and the element above it and below it must be 0. Okay, how can I make it? So first of all I have to convert minus 5 to 1. How can I do it? I divide row 2 by minus 5, so I obtain 1 in here. A new row 2 must be old row 2 divided by minus 5. Okay, so it will be 0 1 0, new row 2. So all the next operations must be done with row 2, the new row 2, this one here. Okay, so how can I make 3 0? 3 it's in row 1, so make it row 1 minus 3 row 2. So every row I want to change it, so I put it as it is, row 1 equal to row 1 minus the coefficient, okay, the opposite sign, see it's plus, so I put it minus 3, the new row I obtain it. Okay, so what I can, so I calculate the result and I obtain, okay, 1 0, okay, 1. Okay, so minus 5 in row 3 also must be equal to 0. The new operations, or the new row 3, it's old row 3. What I have here, minus 5, opposite of minus 5, plus 5. Plus 5, row 2. Okay, plus 5 row 2. I obtain 0 0 minus 2. Okay, so I finish the second element on the diagonal. The last element on the diagonal is minus 2, must be equal to 1, and the elements above it must be equal to, okay, 0, and this one must be 0. Row 2 is already 0, so nothing changed in row 2, and minus 2 must be equal to 1. So what I said, to make any number equal to 1, I divide it by itself, which means row 3, it's old row 3 divided by minus 2. So I obtain 0 0 1. Okay, row 2 it's already 0, so I leave it as it is. Row 2, new row 2 is same thing, or old row 2, 0 1 0. Row 1, 1 must be equal to 0. What I will do is to make the difference between row 1 and the new row 3. Okay, so row 1, new row 1, it's row 1 minus through row 3 should be 1 0 0. In this case I obtain the identity matrix I3, what I'm looking for. Okay, so I finish the first step. I move from matrix A to the identity matrix I3. Okay, so the next step is to start from I3 and use the same operations in here. First step, second step, and the third step. The result would be a minus 1. Let me show you how can I do it. I start from I3 equal 1 0 0 0 1 0 0 0 1. So the first step is I use the same operations, use them in the first step here. Okay, which are row 1 stay row 1, row 1, leave it row 1, 1 0 0. Okay, row 2, it's equal to row 2 minus 2 row 1. Okay, row 2 is row 2 minus 2 row 1. Row 2 minus 2 row 1 will be, okay, the result is, okay, it must obtain, okay, minus 2 1 0, minus 2 1 0, and row 3 minus row 1, row 3 is row 3 minus row 1. It's minus 1 0 and 1. Okay, so the second step is, as I said, I copied the same operations. Row 2 is row 2 over minus 5. New row 2 is old row 2 divided by minus 5. Okay, it will be 2 over 5. 2 over, okay, 2 over 5. Okay, minus 1 over 5 and 0. Okay, row 1 will be, row 1 is row 1 minus 3 row 2. Row 1 is row 1 minus 3 row 1 minus 3 row 2 will be minus 1 over 5, 3 over 5 and 0. Row 3 is row 3 minus row 3 plus 5 row 2. Row 3 is row 3 plus 5 row 2 will be 1, okay, 1 minus 1 and 1. Now the last operations I have to obtain the inverse matrix A are row 3 divided by minus 2. New row 3 is old row 3 divided by minus 2. So I have now minus half, half, and minus half. Okay, and row 2 stayed as it is. Row 2, leave it as it is. Okay, it's 2 over 5 minus 1 over 5 and 0, except row 1. Okay, row 1 is row 1 minus row 3. New row 1 is old row 1 minus row 3, which should be equal to 3 over 10. 3 over 10. Okay, 1 over 10 and 1 over 2. This is equal a minus 1. If you want, I can put it like this. A minus 1 equal, I take 1 over 10 out of the matrix, and the result will be like this: 3, 1, 5. Okay, 3, 1, 5. 4 minus 2, 0, and minus 5, 5 minus 5. This is a minus 1. Okay, this is the inverse matrix of A. Okay, so if you want to verify, okay, if you want to verify the result, you can do it. Okay, you can do it by multiplying, okay, by multiplying A and A minus 1. If I multiply A times A minus 1, the result should be I3. Okay, so if I ask you to verify that A minus 1 is the inverse matrix of A, you just multiply A with A minus 1, the result must be, okay, I3. Okay, so this is an example about how to find, okay, an inverse matrix using, okay, Jordan method. I want just to give you a quick summary. So normally we give you a square matrix A. Okay, you go to identity matrix I using sum operations, then from I to A minus 1 use the same operations in here. Okay, you use them in here, and a condition must be, okay, satisfied in case of determinant is different to 0. Okay, so now let me give you an example about how to solve a system of linear equations, which means I give you a system, okay, with unknowns, okay, and I ask you to find their values. So in this video, I give you an example, a system of linear equations, system S of linear equations, x plus 3y, okay, plus z equal to 10, okay, 2x plus y plus 2z equal to also 10, and x minus 2y minus z equal to minus 6. So the first thing you must to do is to put them in matrices form, okay, like this: A times x equal to b. Okay, A is the coefficients matrix, x is the unknown vector, okay, and b are the right hand values, okay, right hand side values. So how can I do it? Okay, I copy all the coefficients of the unknowns in here. I have 3 unknowns, x, y, z. Okay, the matrix would be like this: 1, okay, 3, and 1, 2, 1, 2, okay, 1, minus 2, minus 1, okay, x are x, y, z equal to b, 10, 10, minus 6. Okay, we notice that the matrix A is same as the matrix A I solved it in here, where I found the inverse matrix for it. Okay, it's the same matrix. The reason why I use the same matrix in this system of linear equations is to facilitate the work. So we already have the calculation, we already have the inverse matrix of A, then I can immediately find I can solve the system of linear equations. In this case, okay, the system I solve it using the inverse matrix A. It's going to do it like this, okay, x equal, okay, A minus 1 times B. Okay, so how can I do it? X equal A minus 1 equal 1 over 10 times, okay, the inverse for it is 3, 1, 5. This is a rule, okay, so can you do it immediately if you have A minus 1? If you don't have A minus 1, I'll show you later how to solve it, okay? But the same concept. 3, 1, 5, 4 minus 2, 0, minus 5, 5 minus 5, okay, times B, 10, 10 minus 6. So now I multiply them. It's equal 1 over 10. I leave 1 over 10 outside the matrices, okay? So how to make the product of two matrices? Row times column. 3 times 10, 30, plus 1 times 10, 40, minus 30 will be 10, okay? The second element, so I have here a matrix of 3 rows, 3 columns. Here I have a vector of 3 rows, 1 column. The result would be, okay, 3 rows, 1 column. Okay, the result is 3 rows, 1 column. 3 rows, 1 column. Okay, so this is the first element. The second element is 4 times 10, 40, minus 20 will be 20. Okay, 0 times minus 6, 0, 20. The last element, minus 5 times 10, minus 50, plus 50, plus 30 will be 30. Okay, equal to, multiplied by 10, 10 over 10 equal 1, 2, 3. This is x, which is x is this one, x, y, z, x, y, z, which means that x equal 1, y equal 2, and z equal 3. If you want to make a verification, you can replace them in one of these equations. For example, x equal 1, y equal to 3 times 2, 6, z equal 3, okay, 1 plus 6, 7, plus 3 equal 10. That means it's right, okay. In this way, okay, you just make a verification to know if your work is right or not, okay. So if you don't have the inverse matrix, I can ask you, like something similar to this example. I give you a matrix A, ask you to find the inverse for this matrix, and the next question will be find or solve a system of linear equations using the same matrix. So you solve it like this way, okay. If not, what you have to do is to put this element, okay. If not, if you don't have the matrix A minus 1, what I have to do is to use the same thing I've done to find the inverse matrix of A. You start like this, okay. You put the matrix A, which is equal to 1, 3, 1, okay, 2, 1, 2, okay, 1, minus 2, minus, okay, 1, minus 2, minus 1. Then you put the right hand side elements, 10, 10, minus 6, 10, 10, minus 6. And what do you need to do now? We call it upper triangular method. So you choose the diagonal elements, okay, and make all the elements below them equal to 0. For example, how can I make 2 equal to 0? I'll leave row 1 as it is. 1, 3, 1, 10. Row 1, leave it as it is. Row 2, I make it how to make row 2 equal to 0, the entry element. Make it 2 minus 2 row 1. Row 2 minus 2 row 1 will be like this. 0, 1 minus 6 minus 5, 2 minus 2, 0, 10 minus 2 times 10, 10 minus 20 will be minus 10. Okay, and how can I make 1 equal to 0? Make row 3, new row 3 is row 3 minus row 1. So 1 minus 1 equal to 0, minus 2 minus 3 minus 5, okay, minus 1, minus 1 will be minus 2, minus 6 minus 10 minus 16. Okay, so from here, if I can have a look, normally all this, as I said, is a coefficient matrix. Okay, the first column is the coefficient, or the coefficients for x. So the first column is for x, the second column for y, the third column is for z. For example, in here, I can deduce that minus 5 times y